All right. So I have a final, and so far I did part one, part two, part three. There will be part four, part five because I have a feeling that the wave, certain part of the electromagnetic things I need to study upon, especially E equal hc, which is the energy equation for a wave. If you know wavelength, you can figure this out. Because there isn't any question on it, but it's in the equation sheet that the professor gave us. So I might have to do it. I will do just one problem, and I have to do a hard problem. So I'm doing the medium and easy and medium questions and a little bit of hard question already. But I have a few questions I haven't done yet that I need to do. And what else do I have to do finally? I'm doing this section because I am trying to explain what I learned because it helps better understand what I'm, you know, doing. Although I gotta admit, uh, it's like a second review section. So we have this question, so you can read it, but there's a large wave. And I always hate this question because you have to go back to 33.2, which makes you go to bring back this diagram, which it took forever for me to find where it was. And after I figured that out, it's quite easy. It's F equal the speed of light divided by theta. Theta equals because of this equation over here. So it's from the last unit where we learned that the speed of something is equal to the wavelength times frequency. Therefore, if you think of it as the speed of light, because we're thinking of light particles right now, obviously we can say that. Now, the first question was standard I deviation of half the massive intensity. So you just divide the max by half. But if you're asking for part C, because I don't consider part A, part B real questions. Oh, I also had to do a practice question quiz. That's what I was forgetting. Anyways, I'll also do that soon. Anyway, over here we get this, and then we just turn to that. And obviously, where did I do it? I got 5550. And what was the question asking? What are the wavelengths? Oh, so you only needed this for part C. Part D, on the other hand, needed the speed of light divided by the frequency, which is nanometers. So you could get nanos, which is -9. So you need to memorize a nano is x to the 10 to the -9. Micro is, I forget, 10 to the 6, I believe, negative. Why do you need to know is because at first the professor gave you these constants, but nowadays they don't. So at this point in time, I gave the professor usually gives like the question, but if he forgets, then it's kind of like, well, you didn't know, so the professor's not gonna fix it because it's like 500 people, so you need to kind of prepare yourself to memorize it. For example, the next equation sheet doesn't have area formula, so I'm gonna have to prepare myself to memorize all of them. So basically, like the surface area of a sphere. Generally, 4 pi r squared is a good one. I'm gonna have to memorize that because I don't trust the professor to put that in the equation because I don't see it in the equation sheet. Therefore, I need to do it. So, what's the tensity if the electron equals this? This means EM. So, EM is max in the equation of sine whatever. This quiz probably won't need that because I've never seen a question where you need a sign. But if it does, I don't I want to know how to do that. But I've seen this question because it's the question the professor gave. Um, but this is given as a constant in the equation, see, so it's not really that hard. The hardest part here is just to know what to do. But if you won't know what to do, you finally get this, and it's like, well, it's pretty easy. The units are the hardest part. So is watts divided by meters per second. So I recommend you don't want to lose like you don't want to lose like minus 0.5 for not having this. And clearly label it because now is the end game, which means that there's the finals happening, which means there's no room for um, finding errors because you're going to leave for summer and you don't want to go back to that. So next, this was like a hard question for me for some reason at first. But once you realize the hand rule, so index finger E on the right hand, sorry. Uh, B is magnetic field, which is the middle finger. So here's why I think of it. B is the middle. You know you hate middle fingers. Electricity is pretty fun, but you're attached with a baggage, a bitch, and that's why I see B as. And then you want to say the middle finger, and that's how I memorize it. So E is the thing you learn first. So you say E first, which is your index finger. The B, as in you don't want that thing baggage on you. I don't want to say that word, but that's how I memorize it. So well, that's such a weird thing to say. So this index finger, I memorize it as E, and middle finger, I said I don't want you because you're such a B word, and then you have the velocity over here for no because thumb is easy. Thumb, your I, and then your velocity. That's how I memorize it. So kind of funny, but so we're traveling a positive direction in X, so we're traveling this way. And because it's Z, so it's traveling this way, the Z, so it's going like this. And over here, the amplitude of what's A asking for? Oh, this is asking for B. So you get it like this, and you get it like this, B max. Parallel to which asset does the oscillate? So it's like this, clearly. I don't know, and then direction is asked by this, so I don't know why they asked this. Oh, it parallels. So it's parallel to the Y field, and this is when what was this again? Positive Z with what's it asking for? Pointed like this. What? Certain point P. Oh, so it's asking this is like this, and if this is like this, no, I don't get it. Sorry. What is Y direction? Yeah, I understand that. Uh, oh, electric field component. Okay, so is in the positive. Yeah, oh, so it's like positive, and oh, so if it's positive, C, it would obviously by the right hand rule be negative y direction because of how I said about E's over here, the B words over here, and the angles over here. So if this is positive y, then this must be going to negative y by the arrangement of how we learn things in Math 20C. So you need to know Math 20C for this one. Basically, the knowledge of the preconception phase. So we decided to say that this over here, this direction is positive, this direction is positive, this direction is positive. Then for this direction, it's negative. Therefore, once you start, if you have if you in the instantaneous speed when the electricity field is going positive y, z, it is this the direction of that is Oh, this is pointless, but I don't know why they put it in here. That's what I was confused about. But apparently, this doesn't change. I was shocked that this doesn't really change over here. If you look at that, it's a little shocking. I didn't think there's no change here. Uh, there's still cosine, and then you can see that this is very interesting that they don't change it. I thought there would be a change, but there is no change in the actual equation here. The only change is the BM, which is quite interesting, which kind of concerns me a little bit. But it makes sense when you think about the equation C equal E divided by B. That equation is so interesting, but it's not really that important. So I can move on now. I don't think that the question is necessary. Now, this is a question I hate because the professor did not put the area equation for this test. So you will need to know the area equation. Luckily, this question has short answers. Flat disk, therefore I could just say it's a circle. But if it's a surface area of Earth, you would need 4 pi r squared. And I need to memorize it now because the professor's not going to give it on the test day. So it's not hard to memorize. It's very simple. Because it's a joke to memorize it. But last test they had it on the equation sheet, and if I was to make an equation sheet for myself, like other physics teacher, I would put that in there. But whatever. Their choice. It's not hard to memorize. So if this was not oh my god, my brain's going brain fart mode. If this wasn't a disk, it would be 4 pi r squared, and it would be divided by 2 because only one half would be permutating showing, and it's absorption because it doesn't reflect back, technically speaking, gets absorbed. And that's why this equation works. I hope this equation never shows up on the test, but it's whatever. And the part B was asking for the pole of the sun, which I was saying, nope, not doing it. Just because this was the same number and I didn't want to do it. So I just did this. I just put this in here. Nah, not doing that. So this is a fun one. So, oh, right. I don't quite. Let me check something. Now, the thing about this equation is that once it goes down to 1, it always changes to 1/2, which is, I believe, why they say 1/2. But why is this a percentage? How did they get a percentage? Because there's the initial value here, and I didn't show how they got that. Yeah. But the most important part about this question is that if you could have a what are these called, polarizing direction, it always divides by half, no matter what polarization screen you put up, due to the fact that how do you say it? Due to how the light works. The reason, but if you have two of them, you cancel them out, right? You would think if you do 90-90 interchange, but if you actually have another plate in between, because of how light works, for example, these two are same angles, but because of how light works, there's actually still intensity going out. So these two have same angles, but because this equals half and this change. So imagine this: light is going here, and the light is changed into this direction. And over here, when it hits this, the light is changed into this direction. So when it goes here, it turns into this direction. Sorry. And when the light hits over here, it goes back to this direction. Well, if this wasn't here, it would, and this over here was 90-degree this way, contrast to this, it would be completely zero intensity. But uh, like this. But because there's some this part over here, that effect doesn't show, and this cannot be canceled out. I got tricked by this question because I canceled this out by because they're the same angle, but you can't do that. Um, that's the whole point of that question, and it's to make you think about that, and then trying to find the uh, like some equations here. Oh yeah, phasor diagram. We need to talk about that later on for another class. Don't worry about that yet. But yeah, I don't see where this is. Shit, my text. Me too. Oh yeah, so there's nano, milli, cento, kilo, whatever. Okay, I don't see it. I'll have to review that later on. Okay, so next thing over here, this is more normal. So this is minus so this is half over here. We get half, and then these two angles are minus to each other to get you the intensity final. And then these are the more normal questions that we're going to get on the test because this unit is heavily focused on it. Probably because I've seen the previous tests and practice tests. It's easy, right? No, I mean this is easy right now, but that's because we just follow equation of n's this equation here. This is pretty easy too. This is just using, actually not really easy if you don't know geometry really well, but I know geometry well and I can figure this out. And I can figure out the angle of this very easily. Wait a second. I might actually be wrong here. I think I'm wrong because I think you're asked for this angle probably. Um, Show light reflecting from the two perpendicular for A and B. Find the angle between the ray. What? Oh, no, no, not right. Oh, so they're asking for this array compared to this array, but they're parallel to each other. So therefore, there is zero difference between these two. So the angle difference would equal zero because there's no change in the uh, change in the density of it, and no angle change. So what is this asking? Ah, right. So I changed into this format, but you're actually supposed to make it look like this. So I want to say that in this case, if I have something like this, and it has a right degree over here, 90 degree, I should probably show different colors, um, because this is a part that I found intriguing. So if this is a huge amount of light, there's actually some light coming out of here to this in a perfect angle like this, and that reason is important because for example, if there's a few questions where they ask this question, like, what will happen if this happened, which the angle is now in this ballpark, but that won't happen. Instead, it will be a perfect reflection. Uh, it'll be reflection, not refraction. Refraction is this, and then if you go under here, there will be refraction here. And you see how wording that is so confusing, but I've seen these questions before, and they're not. Hopefully, they won't be that bad. Okay, so Um, these are not bad. These are asking for this and this. That should be quite easy with this equation given. Not really easy if you actually want to derive it because that's derived by this equation. So good luck solving it if you want to derive it. But textbook gives you that equation, so why the fuck would you uh, mess with it? So just a plug and oh, this is a tricky one. So this is airplane, and the airplane one is funny because the average electricity and the average magnitude um, has is same as E max. So that's the whole point of this, and you can figure it's very easy. And also, you need to know the ratio of this. Uh, in the textbook, it shows about E max and E max, but there's actually a ratio for any two of these. So equals C in a function of time of how it functions in time and space, and you can figure that out in your own time. What was this again? Yeah. Oh yeah, this is just getting the power of it, which is I didn't do watts here, which is needed. As you can see, the radius is so important, and I believe this question sucked because this question also. Oh, they show the radius, so uh, it was um, how is that? Oh my god, where is the? Didn't they say like hemisphere or something? Hemisphere, which is why it's 2 pi r squared because it's actually 4 pi r squared divided by 2 because that's the surface area of the half. What is this one? Oh yeah, reflection. Basically there's a sun and this time there's a reflection, so you have to actually do this. Why do I say it's equal to gravity? Um, almost the surface let's say it'd be if the radiation force is equal to the magnitude of the sun's gravity, assuming yeah. We assume that they're the same and you just have to figure it out. Unfortunately, the mass of here is negligible, uh, which I didn't delete, surprisingly. I would have thought I'd delete that 15 kilograms because it would have been negligible, but I kept it in there, which probably is a better idea. Thinking about it. Yeah, it gives you a surface area something close to this. But if you really wanted to, because the mass is so actually No, you have to keep it in there. I'm being stupid. Sorry. You have to keep the mass in here and the double mass and the radius of the. Yeah. Oh, this is a hard question. This is a very bonkers question. But it's basically using the. I recommend you memorize this question, and if the professor gives it on a test, you can regurgitate it out. That's what I'm gonna do because to me it is. Well, A makes sense. I explain A. It's basically 99 over here, but B is where it gets troubling, where you have to figure this out, which is given by the weirdly worded text over here, which gives you this. I don't like the wording of the text, but that's how you do it. Uh, if you divide this by IO, you get a 1/2 for the first one, I believe. And that's what should happen. If it doesn't, then I'm wrong. I'll, I'll see what happens. I forget. But yeah, that's how you do it. You basically plug and chug until you get this. This is the equation you plug it. Yeah, it's just a painful question that I hope the professor doesn't give. Because I didn't understand it, and then I went to the discussion section and they told me how to do it. This is more plug and chug. Yeah, and this is the pressure, radiation pressure on the sheet, which is PA. So it's PA, and also don't forget V divided by M. I kept on forgetting about this. Now these are the fun questions. So fun because they're geometry. So because they're 90 degrees, it only works on a plane like this, a parallel plane. We can have it equal to this kind of wonky thing only because of that. And this one's a little bit weird because it's angles like this and you go up to air, which is pretty easy. The B is where it gets hard because it's N1 sine made up all the way to phase 4. But once you know that this equals this, you have a straightforward path to getting the answer correctly. Okay, we're done with the section. So, what's this? Enters a plane. Oh, so part. Oh shit. So one thing you need to know that the angle of 3 is this is this, it should be the same angle over here. Did I get the same angle over here, or did I not do this correctly? Yeah, it should be the same over here. So it should. Yeah, it should be the same because I forgot what the word is. Um, the shit. The n value is the same. So imagine having n1 sine theta. You can actually test this out. Why don't we test it out? Because I don't think I can explain it correctly without testing it out. And if we have this, and what was the angle again? Oh, is this the one with two different lights? Oh yeah, this says red light and blue light. Um, yeah, it's gonna be fun. Thing about red and blue light is that if you have water here, and let me see if I remember it correctly. So there's light over here coming through over here. Then I believe because the density of here is n equal 1.33, um, the blue comes first, right? If I remember correctly. I might be wrong about this, which because we're done with explaining this part, I can go over here, go to this one over here. Here it is. Oh, it's red first. Red leaves first, and then blue. And then if it's out of water, yeah, sorry. So I guess I need a new way to memorize this because I freaking failed. So in water, because the water looks blue, red gets out faster is my explanation. I guess I don't know. Then blue looks more. I don't know. That's how it works, anyways. Okay, so that's how you do it. And if water is at the top and light comes in over here, the knowledge that if we have this blue is first and then red, as we have seen over here. Oh shit, I'm doing the wrong way. Sorry. Confunction. So sorry. Is blue blue first over here and then red second when light comes in. Yeah. What happened? I don't know what happened. So I must have pressed this by accident. I don't know why. Um. Anyway, what was I about to do again? If this was water, then now I was just going to tangents and see what I can figure out. And there's light coming out of here. Then blue would be first, and then red would be second. So blue would be first over here, and then red would be second over here. Interesting, right? I didn't even think about that. Maybe that's why we see blue first. When we see light coming outside of the ocean, that's what happened when we light penetrating inside. The deeper we go, we see blue. Never thought about that. Anyways, n was one, right? So imagine having assigned this equal to what was n over here. Let's just go with the red one, 1.509, and then sine over here by some angle. Then we have again back to 1 and it's signed by 50 because they have to equal each other. If this is 1, then this must be 50. Therefore, the angles are different. That does not mean that the light is different, although. Um, when this one over here, because this is thicker, this is acting like water because it's higher than 1, higher than the outside. So you can think of this as air and water. So if I thought of it like that, I would say that because water, we said red goes first. Red would be like this, and then it won't be that deep, but it'll be something like this. And as you can see, even if they go to the same, oh shit, even if they go out the same, they have the same angle. It could be that like a prism where it leaves with a different spread. That's how rainbows are made by similar properties that we'll talk about later, hopefully. I hope that makes sense. If it doesn't, well, just I need to make sure I remember this. Blue in, think of the blue and it's deeper, and when it gets out, we see blue first and then red later. Yeah. All right. Here is another question that we have. Well, over here, I use the process of just plugging a bigger number, bigger angle, and seeing what happens. I don't have the patience to conceptually figure this out like forever and think sine, cosine, and now it's gonna be like how because of reflection the starting angle is smaller. This happens and this blah blah blah. No, 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 no. You get the equations, you plug it in, and and then if you're asking for a bigger angle, just make a bigger angle and say that is true. And once you figure out it's true, then good job. So yes, material three goes to goes to because we found that because I think this gets a bigger angle and like this, and then it goes like this or something. Because that's the only way that makes sense. Because this got bigger or something, right? Well, anyways, you can plug it in and do it like that. And this is why critical angle is important because I got tricked by this at first. How is this a critical angle? Well, the reflection doesn't mean there's no critical angle here. It's just that there's a reflection too. But critical angle generally means that this is a perfect angle that this is reflecting over here. Well, okay, so this is a hard No, no, this is a hard one. Yeah, this is basically you have to think of it like this, and then you have to go with x